we have to solve this word problem. This problem says that all living organisms contain and renew carbon-14. Once something dies, it stops producing carbon-14, and the amount of carbon-14 in the body begins to decay at an exponential rate. An archaeologist finds the remains of a mastodon, and it is found to have 20% of the normal amount of carbon-14 in its bones. Approximately how long ago did the mastodon die? To solve equations involving exponential decay, we use the equation A equals A0 e to the RT, where A is the final amount of a material left after decay, A0 is the initial amount of carbon in a body or amount of material that we're dealing with, R is the decay rate, and T is the amount of time. Now, for exponential decay, we have a standard formula for calculating R. Our decay rate is always equal to the natural log of 0.5 divided by the half-life. Now, in order to do this problem, we do have to know that the half-life of carbon-14 is 5,730 years. Once we know that, we can now fill in 5,730 and find our R. Now, sometimes we might choose to do this problem using a lot of long decimals because you do suffer from rounding mistakes in this sort of problem. What I'm actually going to do is I'm just going to leave my R as the natural log of 0.5 divided by 5,730. That is just one number. I'm going to go ahead and put in my T, and then I'm going to look at my A and my A0. Now, this problem does have one twist to it. A lot of times in the problem, they tell us how much material you start with and exactly how much material you have when you're finished. This one doesn't tell me how much carbon-14 is in the body originally. So we're just going to leave that as A0 for right now. We don't know what that number is. They also don't tell me exactly how much carbon was in the body when it was found, but they do tell me that the amount that was found is 20% of, which means times, the original amount. So what that means is that I can replace my A with 20% times A0. Make sure we never use a percentage when doing a problem. We need to convert 20% to a decimal. So 0.2 A0 is our A. So our final amount is 0.2 times A0. Our initial amount is A0. I don't know what either one of those amounts are, but as we're going to see in a minute, it doesn't really matter. E to the natural log of 0.5 times T. Now, we need to solve this equation. In order to solve this equation, the first thing I want to do is I want to get my E by itself, my E with its exponent by itself. So I'm actually going to divide both sides by A0 to cancel that A0 out. Notice when I cancel out the A0 on the right side, I'm also going to end up canceling out the A0 on the left side, which is why A0 does not matter. And my equation now reduces to 0.2 is equal to E to the natural log of 0.5 over 5,730 times T. Work over here. Rewrite our problem. Now I have an exponential equation. I need to get to that t, and the t is in my exponent. Well, in order to solve this equation, what I need to do is I need to rewrite my exponential equation in logarithmic form. I will remind you of our definition, which says if x is equal to e to the y, this is an equation in exponential form, we can rewrite that equation in logarithmic form as y is equal to the natural log of x. This is our definition for logarithms. In my problem, our x is simply 0.2. Our y is this entire expression here. So rewriting my equation in logarithmic form would be the natural log of 0.5 over 5,730 times t is equal to the natural log of 0.2. Now, I need to solve for t, and my t is being multiplied by something that looks like a fraction. It's a funny looking fraction, but it's really just a fraction. And to cancel that fraction out and get t by itself, all I need to do is multiply by the reciprocal of this expression. So I'm going to multiply the left side by 5,730 over the natural log of 0.5. Notice what that's going to do on the left side. These will cancel, and I'm left with just t. Of course, if I multiplied the left side of my equation by 5,730 over natural log of 0.5, I'm also going to have to multiply the right side by 5,730 divided by the natural log of 0.5. Now, this is not a calculation that we can do on our head. However, I have already done this calculation, and it turns out that this answer ends up being about 13,305 if we round that to the closest integer. So it turns out that this mastodon, if it had only 20% left of the carbon left in its bones, must have died around 13,305 years ago.